Coral reefs are dying and fast due to rising temperatures, but what if we could train them to survive the heat?
Today we're diving beneath the surface to explore one of the most consequential technologies in ocean science. Rising ocean temperatures are wiping out coral reefs, and we've already lost half since the 1970s. But first, what exactly is a coral reef? Coral reefs aren't just ecosystems, they're a living infrastructure built by tiny marine engineers called coral polyps. Over millions of years, these animals have constructed massive underwater structures made out of calcium carbonate, forming vibrant habitats that support nearly a quarter of all marine life. These ancient ecosystems have existed for over 500 million years, long before dinosaurs ever roamed the Earth. They survived asteroid impacts, ice ages, but now they're facing something new: rapid, human-driven climate change. Luckily, scientists are not giving up. They're turning to innovation, using biotechnology, selective breeding, and engineered resilience to help corals adapt and maybe even thrive in a hotter future. To see how, let's go to field reporter Luke at Arizona State University's Coral Research Lab.
Thanks, Cody. I'm here at the Coral Lab inside ASU's Walton Center for Planetary Health. Yes, coral reef research in the desert. Scientists here are training corals to take the heat, literally. They're using a process called assisted evolution, which helps corals adapt to warming oceans. One method is thermal conditioning. It's like a boot camp for coral. By exposing them to small doses of heat stress in the lab, corals build resilience to survive future heat waves. Think of it like training for a marathon. Stress now, strength later. Coral restoration began in the 1980s with simple techniques like transplanting fragments, but by the 2000s, as coral bleaching became more severe, scientists needed new tools. In the 2010s, researchers began designing corals for resilience, using lab-based techniques to reimagine what corals could be. By 2020, they were pairing heat-tolerant algae with coral larvae, bioengineering next-generation corals to survive in a hotter world.
So how does this research actually make its way to the ocean?
One method, coral nurseries. These are underwater structures or land-based tanks where strong corals are grown, fragmented to encourage rapid growth, and then transplanted onto reefs. When this works, the impact is huge. Reefs support 25% of all marine life and the livelihoods of over 1 billion people, per NOAA and the United Nations. Coral reefs play a pivotal role in fostering abundant and diverse fisheries and also provide habitats for toxin and carbon-capturing organisms like sponges and phytoplankton, demonstrating corals' profound impact on ocean biodiversity. Coral reefs don't just protect coastlines. They support the fish you eat, the air you breathe, and the economy you rely on. Compounds found in reef organisms are used in life-saving medicines, from cancer treatments to chronic pain relief. From the supermarket to the public park to the hospital, everyone is impacted by coral one way or another.
Of course, it is not all smooth sailing in the coral rescue mission. These technologies face some real challenges. For starters, they're expensive. Running coral nurseries, high-tech labs, or deploying robotics takes serious resources. And a coral that thrives in a lab might not survive in the ocean. Long-term resilience and reproduction are still being studied.
And there's still some debate. Some scientists urge caution. Could these engineered supercorals outcompete native ones? Could focusing on heat resilience make them more vulnerable to disease? And most importantly, these innovations don't solve climate change. They buy time. Reversing the man-made pollution trends of the last several centuries is no small task, but cutting emissions is still essential. And here's a key point. This research is only possible thanks to public funding. Universities like ASU are leading the way because governments fund science in the public interest. Coral reefs are a public good. Everyone benefits, but no single company has enough profit or short-term incentivization to fund this vital work alone. While nonprofits and governments have largely met the moment, it's worth noting that recent uncertainty in funding for scientific research, particularly in the United States, pose a significant risk to coral reefs' future prospects. Large budget cuts proposed for NOAA in 2025, for example, could grind crucial university research endeavors into cutting-edge coral technology to a halt. While the scale of the impact of university research can be hard to perceive, the harm brought about by stopping it extends far beyond just coral health. University research into coral reefs has driven developments in remote sensing, mapping, medical technologies, and beyond. Universities are an invisible hand that we need to recognize for the creation of new knowledge and for their role as repositories of scientific discovery. functionality that has allowed the United States to be the global leader in innovation.
Some of the most advanced ideas kind of sound like science fiction. Nanotech and bioprinting are entering the coral conversation. Let's go to Luke, who's with a scientist pushing these frontiers.
I'm here with Dr. Lisa Roger, a coral scientist exploring high-tech solutions.
I started here at ASU in 2022. We specialize in looking at corals at the cellular level. So in the past, people would take all the tissue, so do a tissue slurry and analyze that. So fix their sample, freeze it, for example, and then do their analysis on this. The only thing is what you get is a one-time response. So what we're able to do now is to dissociate cells from corals and then grow them in culture and look at their response in real time. And the specific response that we look at is the response to thermal stress. Really, temperature is our main focus at this stage because it's the most pressing issue.
So who's making this happen?
It's a global team effort. Scientists, marine biologists, ecologists, engineers, lead the lab work. Divers and conservationists manage reef sites and nurseries. Local communities and indigenous groups contribute traditional knowledge and care for restoration zones. Governments fund projects. NGOs and international programs help coordinate and raise awareness. Even everyday people help by choosing reef-safe sunscreen or supporting reef-friendly businesses. The continued health and future prospects of coral reefs fully depend on careful coordination between each of these groups. And right here at ASU, we're seeing what that collaboration looks like in action. The new Akoʻakoʻa initiative, a partnership between Arizona State University, the University of Hawaiʻi, and a conservation nonprofit Kuleana Coral, is working alongside local cultural leaders and West Hawaii communities to restore 120 miles of reef along the Big Island's west coast. When complete, it will house the world's largest coral propagation facility, combining state-of-the-art research with deep cultural stewardship to build reef resilience for generations to come.
The next decade is critical, but there's reason for hope. Some heat-tolerant corals are already showing success.
We could soon see super coral nurseries and advanced restoration strategies taking root around the world. It may not look like much now, but these fragments represent possibility. If we act now, and pair science with climate action, reef recovery is still within reach.
From labs using nanotech to reefs being replanted with tough corals, it's amazing to see human ingenuity rising to meet this challenge. Coral reefs are critical for nature and people, and now we have the new tools to help protect them. This mission to save our reefs is far from over, but as we've seen, it is absolutely unstoppable when scientists, communities, and innovators work together.